Okay. So we finished part one. That's what the test was on. So today we'll start part two, which is linear systems. And there are three parts, three sections. So we'll do section 5, 6, and 7, and then have another chapter test on the whole section. So this section is linear systems, and this part is linear systems, and this section is going to be systems of linear equations in two variables. And so it starts on page 124. I'm sorry, I normally have a presentation ready, but I have an issue with my computer, so I don't have it up here. So we'll do it the other way as we go. Okay, the idea is that if we have two systems, or I'm sorry, two equations, that forms a system of linear equations. So let's come up with two equations. Let's start with 4x plus 3y equals 5, and 2x minus 5y equals negative 17. So these are two different equations, and when we put them together, we call it a system of linear equations. And if there is a coordinate, if there's an ordered pair, an x value and a y value, that will make both of those equations a true sentence, or a true statement, then we call that ordered pair, xy, the solution of the system of equations. Okay? So if there is an ordered pair that will satisfy both equations, then that ordered pair is the solution of the system of equations. Okay. So there's a few different ways you can do to find out what that ordered pair is, to find the solution. There are a couple different techniques, so we'll do both. So, and they call it a little something different in the book, which is fine. But these are really the two ways that you're going to do it are through substitution or elimination. So the first one I'm going to show you is elimination. In order to solve it through elimination, it's going to start that. Okay. In order to start it through elimination, you have to get rid of one of the variables. Okay? So in order to solve this, you need to either have y's or x's, but you don't want to have both. Okay? So you can transform one of the equations so that you can get rid of it. So the idea is that I'm going to add these two equations together. And in order to add them together, you want to add them together so that one of the variables will drop out or be eliminated. Okay. So you know through Algebra 1, in the beginning of this algebra, that if you have two things that are equals to each other, you have an equation, this side's equal to this side, you can use the addition or subtraction property of equality, and you can also use the multiplication and division property of equality, which means you can multiply both sides of the equation by the same thing, and you'll still have an equivalent statement. So the idea is if I want to eliminate a variable, I'm going to have to multiply both sides of the equation by some number in order to make them drop out. So for example, in this very first problem we have here, in our second equation, if I multiply everything by negative 2, I'll get a new equation. So I'll keep my 4x. I'm keeping my top equation the same. I'm not doing anything to that. What I'm doing is I'm transforming or changing my second equation by multiplying everything by negative 2. Okay? So if I do that, I'm going to use the distributive property here. And negative 2 times 2x is negative 4x. And if I multiply negative 2 by negative 5y, I'll get positive 10y. And then if I multiply negative 17 by negative 2, I get positive 34. So I have kept my top equation the same, but I've changed my bottom equation. And this is a true statement as well, because I can multiply negative 2 by both sides. Now notice that when I do that, when I add these equations together, my x variable is going to drop out, because 4x minus 4x is just 0. So all I'm going to have left is 13y equals 39. And if I have 13y equals 39, well, you know how to solve that. I can divide both sides by 13. And y will equal 3. So I know y equals 3. I still need to know what x equals. So I'm going to take my equation up there, 4x plus 3y. 4x plus 3y. And what did I say it equals 5? And if I substitute in what I know y equals, which is 3, I should be able to solve for x fairly easily. So 3 times 3 equals 5. 3 times 3 is 9. If I subtract 9 from both sides, I get 4x equals negative 4. And if I divide both sides by 4, I get x equals negative 1. So I have a solution set x equals negative 1, y equals 3. And so that coordinate, that ordered pair, is said to be the solution of that system of equations that I gave you. And notice that if you went back in, negative 1, 3, let's write it over there. And if you went back in and put those numbers in, if I put negative 1 here and 3 here and solved it over, they should both give you a true sentence. So negative 4 times negative 1 would be negative 4. 3 times 3 is 9. Negative 4 plus 9 does equal 5. And if I put a negative 1 in here, that would be negative 2 minus 15. Negative 2 minus 15 is negative 17, which was also a true statement. So that is our solution set. Okay. So that's one way to do these, is through elimination. Well, let's do it a different way now. I'm going to use the same system of equations, 4x plus 3y equals 5, and 2x minus 5y equals negative 17. So for some of you, that elimination may be the easiest way to solve that. But for some of you, maybe not. So another way to do it would be to solve one of these equations for one of the variables. And it doesn't matter which one. So let's say I want to solve it for, I want to solve this for x. Okay? If I want to solve that for x, 4x plus 3y equals 5. Well, what does x equal? If I want to solve it for x, that means I want x by itself on one side of the equation. Well, I would have to subtract 3y from both sides. My subtraction property of equality. That would leave me with 4x equals 5 minus 3y. And then I could divide both sides by 4. And I would get x equals 5 minus 3y over 4. And so that's not as nice as x equals negative 1, but that's what x equals. And so now once I've solved it for one of the variables, they call this the substitution method. And the reason is because I'm going to substitute what x is back into for x in the other equation. So my other equation was 2x minus 5y. 2x minus 5y equals negative 17. And again, the reason they call it the substitution method is because I'm going to substitute my x, which is this, in for x to solve. Okay? So if I have 2 times 5 minus 3y over 4 minus 5y equals minus 17. And so now notice now I have a new equation with only one variable in it. No x's, only y's. And then I can solve this for y. In this particular problem I gave you, this first system of equations, I think you will find if you did them both ways that first way I showed you, the elimination, will be a little bit easier to do. That's not always the case. Sometimes substitution's easier, but let's do it just to do it. All right. So if I'm going to multiply these together, this is just 2 over 1. And I'm going to multiply 2 times a quantity. I use the distributive property. So I would have 10 minus 6y Does everyone see where I got that from? 2 times 5 minus 2 times 3y, all over 4 minus 5y equals minus 17. Okay? Now, in order to subtract fractions, notice what you have here. You have 5y is over 1, because if there's no denominator, it's over 1. And so what do I do if I'm going to subtract fractions? I know fractions, some of you get nervous. What do I do if I subtract fractions? What do I have to have? Anyone? A what? Someone said it. A common denominator. Well, these aren't. So if I wanted a common denominator, I could keep this 10 minus 6y over 4. But I would have to change this. So if I multiply this by 4, I have to multiply the top by 4. That would give me 20y. And so some of you don't like fractions. So this particular problem, if you did it by substitution, would bother if you didn't like fractions. Okay. And so now I can just subtract across the top. And by subtracting across the top, I'll get a common numerator over 4. So 10, and what's 6y minus 20y? Anyone? 6y minus 20y. Minus 6 minus 20. Minus 26. Okay. Just making sure we're all over 4 equals negative 17. And now it's pretty much an equation that you know how to deal with, because you can multiply both sides by 4, just leaving you 10 minus 26y. And 4 times 17 is 4, negative 68. Okay. And then I could subtract 10 from each side. 78. And then I could divide both sides by negative 26. And I think I would get y equals negative 3. I'm sorry. Oh, I'm sorry. Good. Positive. And that hopefully is what we got when we did the first one, right? We got y equals 3. Hopefully. Where was my thing? Yes, y equals 3. And then once you have 3, you could just do the same thing back to the other side. You put your 3 in for y, solve for x, and your x would be negative 1. So I won't re-solve that. That's the same thing we did before. Both methods will work. And you'll find that I know that we did those examples, and the first thing you're thinking is, why would I ever want to use that substitution method? Well, in this particular problem, that was more difficult. But there are some systems of equations. If, for example, they gave you the equation of a vertical line, what's the equation of a vertical line? X equals something. I'll call it, x equals, I'll put a number sign because it's going to equal something. But, x equals A is what your book's going to say. But sometimes that confuses you, because what does that mean? It means all your x values are at the same point wherever it crosses the x-intercept. And what is the equation for a horizontal line, Micah? Y equals, your book's going to say y equals b, some number, wherever it is, because all your y values, notice on a horizontal line, are the same, namely the point where it crosses the y-intercept, or where it crosses the y-axis. And so that was a good review from last section. But also, if you have something like that, if they give you a system of equation where one's a vertical or horizontal line, well, the substitution is going to work really nice, because wherever x is, you're just going to put in whatever the number is. It's already done all that other stuff that we did to solve it by itself. So there's going to be times that one will work better for you. And so you're going to try both. Now, let's do one rather than say if. Let's do this. We have minus 3x plus 5y equals negative 6. And we have 6x minus 10y equals 12. Okay. So if you have this sort of an equation, and you go to solve it, I want to get rid of one of my variables. So which variable do you want to get rid of? You can do it for either one, Maggie. Which one would you like to get rid of, the x or the y? And there's no right answer. It's whichever one you want to do. All right, you want to get rid of x. So here you have minus 3x. Here you have 6x. So those have to be opposites in order to get rid of one of them. So you're going to have to multiply one of those equations by something that's going to make it the opposite of the other. So which equation do you want to multiply? The top or the bottom one? The top one. What would you multiply it by in order to get, you want this to be a negative 6? 2. Because 2 times negative 3 is negative 6x plus 10y equals negative 12. Okay? Now, so I'm there. Add these together, Dominica. What am I going to get? What's 6x minus 6x? 0. What's 10y? I'm sorry, minus 10y plus 10y?
0.
What's 12 minus 12? 0 equals 0. Well, what help is that to us? Oh, you got a 0. You got all your variables gone. What does that tell you if you come out to 0 equals 0? Well, it tells you that what you just did is you subtracted one equation from another, and you got 0, which means those equations are exactly the same. Those equations aren't different. And notice this. If you multiply it by 2, you got the opposite. But if you multiplied it by negative 2, what would happen if I multiplied this equation by negative 2? And you can multiply both sides and equal sides by any number you want. I'd get negative 2 times 3x would be 6x. Negative 2 times 5 is minus 10y. And 12. And notice, these two equations are exactly the same. That's why you got 0 equals 0. And so those are the exact same lines. And so that's what that will tell you. So once in a while, if you get a system of equations, that if you have two lines that are exactly the same, that means every point on the line will work. In other words, every xy you put in. Pick an x value, Michael. Pick an x value. 10. Okay. If x is 10, what is y, Michael? That would be, if that's 10, that's minus 30 plus 5y, equals negative 6. If I add 30 to both sides, I get 5y equals negative 24. Okay, 24 fifths. If you took that ordered pair, Michael, and you put it back into this equation, it would still give you a true sentence. But by the way, if your x value, Megan, would have been negative 312 over square root of 3, and you solved that and got a y, I'm not going to take the time in class with that, but if you solved and got some number, that would also work in this. Any xy that will satisfy one will also satisfy the other one, because they're the exact same line. Okay? That's the idea with the... And when we say that those points, those lines coincide. So if you see that word on a worksheet or on a test or a chapter, those lines are said to coincide. They're the same line. You might have, some of you took geometry, you remember that. Some of you don't. Okay. Let's see. Somebody remind me what time this class ends, because I only know the regular schedule. I don't know the chapel schedule. How many minutes do I have? 16 minutes. Okay. Let's do another one, and then you can start on your homework. So let's pick an even one, since you're doing the odd ones for homework. Pick an even one, Maggie. I don't care. Pick a number that's even.
Okay.
Yeah, sure. Number 8. Everyone's looking up here, right? Number 8 is 5x plus 6y plus 8 equals 0. Oh, and 3x plus 6y. Oh, no.
Minus 3.
Yeah. 3x minus 2y plus 16 equals 0. Okay. All right. Courtney, let's do this. So, do you want to do substitution? You will do. Substitution or elimination?
How did the combination choice?
What's that?
The first one.
Elimination. Okay, you want to eliminate one of the variables. Which variable would you like to eliminate? The x or the y? I'm game, whatever you want. It'll work with either one.
Y.
Just pick the one you want. All right, y. So, this is negative 2y, and that's 6y. So, to eliminate the y's, you either have to turn this y into negative 6y, or turn this into negative, or positive 2y. Which one?
So
You do-
multiply the bottom one by
That makes more sense. Otherwise, you got a fraction. You're going to be doing. Either one will work, though. I promise you. You could do it as a fraction, and the other way would work. But this way is the simpler way. Good. So what am I going to multiply that by? That whole equation in order to turn that into a negative 6y.
3.
Good. I'm going to multipy by 3. And so if I multiply that equation by 3, I'll have 9x minus 6y plus 48, and still equals 0, because anything times 0 is still 0. Did I? Yes, okay. Now, I'm going to sort of pretend that this isn't here for a minute. And Courtney, I'm going to add those equations together, and what am I going to come up with?
So 14x
14x
plus 0.
plus 0.
Cancels it out.
Uh-huh.
Plus 56 equals 0.
Good. Plus 56 equals 0. And then, what am I going to do, Sam, to solve this? What's the first thing I'm going to do?
Is it y?
Nope, the y got.
Oh yeah, this.
She was eliminating the y while you were packing your backpack. So what are you going to do to solve it with this one?
56.
You're going to subtract 56 from both sides. Good. And what am I going to be left with, Sam?
4, like x equals negative 4.
Well, I'm going to be left with 14x equals negative 56. And then Sam wants to divide by 14. He skipped us. He went one step ahead of us. And then x is indeed 4. Good. So if x is 4.
Negative 4.
Was it a negative 50? Yes. I'm sorry. I didn't see the negative there. Negative 4. Okay. And so if x in fact is negative 4, then what is y? Well, 5 times negative 4 is negative 20 plus 6y plus 8 is 0. And so what am I left with up there? 6y minus 20 plus 8 minus 12 equals 0. Add 12 to both sides. Divide both sides by 6. And y equals 2. So, I believe the solution set is 4, 2. And if you actually, and you should do this, you get to the bottom, I know what you want to do, the same thing the Algebra 1 students do. You want to get to the end and put that box around it and move on to the next problem. But if you take 2 or 3 minutes, you can decide to eliminate any minor math mistakes. So if you take the negative 4 and the 2 for your x and y and substitute those into both equations and then solve them, if they come out to some number equals the same number, and then this one would be 0, hopefully this would come out to 0 equals 0 and 0 equals 0, then you know you have the right answer. If something happens and you get to one of those equations and you get something that says negative 3 equals 0, all that tells you is you made a math mistake somewhere, you need to go back. Remember, I forgot the negative 56. I didn't see the negative sign, so I put the negative. So I had negative 2. If I just left it like that and think, well, jeepers, I'm smart, I know math, so I move on to the next one, I'm going to lose 2 or 3 points of partial credit because I just missed a negative. Whereas if I went back and put in the -2 and I'd say, oh, that doesn't work, what did I do? Then I'd go back and say, oh, I missed my negative. And so do that. Take those, especially, even if you're not going to do it from the get-go, do it after the test is over when you still have a few minutes left. Instead of handing it in 5 minutes early, go back and check some of these things. And then you'll know. You'll be able to catch those small mistakes so that you can get it and you know what you're doing. Are there any questions on today's section? I think you have about 3 minutes left if my math is right. So you can start the homework now. It's going to be graded. It's page 129, 1 to 37 odd.